You are welcome to today's course. Today we're going to look at the laws of chemical combination. As you can see, these are the laws that make up the law of chemical combination, the law of conservation of mass, the law of definite proportion, the law of multiple proportion, and the law of reciprocal proportion. The law of chemical combination is talking about the interaction of atoms and molecules to form compounds, or the interaction of elements and other elements to form compounds. In today's course, we're going to look at the law of definite proportion or constant composition. I'm very, very excited of what you're going to learn today. You are going to love it. The law of definite proportion states that a given chemical compound always contains the same element in same fixed proportion by mass, regardless of its source. For example, water, which is H2O. This law is telling us no matter the source of H2O, whether from the river, this water, whether it's from the river, whether it's from the rain, whether it's from which other source? Lab. It must contain the mass of hydrogen and oxygen must be in the same fixed proportion by mass. What is it telling us? Like hydrogen in water, the atomic mass of hydrogen generally is 1, while the atomic mass of oxygen is 16. However, in H2O that we are talking of, because we have 2 here, it means that in H2O, the atomic mass of hydrogen will be 2 multiplying 1, which is 2 grams for hydrogen. Then for oxygen, the atomic mass remains 16 grams. And if you look at it very well, if you take the ratio of hydrogen to oxygen in H2O, if you divide this by 2 to give you 1, if you divide 16 by 2, it will give you 8. It means for H2O, water, the quantity of hydrogen to oxygen must be in the ratio of 1:8 by mass. Now, look at this again. Let me show you this. So, assuming you have hydrogen and oxygen in H2O. So, for every hydrogen, you have 2 grams. For every oxygen, you have 16 grams. That is in H2O. So, assuming that we increase the mass of this oxygen by 32 grams, it means that the mass of the hydrogen is going to increase by the same double. Assuming we'll increase the mass of oxygen to 48 gram, which is multiple of the original, it means that the mass of hydrogen is going to increase 3 times as well, which will give us 6 grams of hydrogen. Now, if you check the ratio, 6 divided by 6, so the mass, so can see that 2 of them increase in the same fixed mass. If this increased by 3 times, this will increase by, if this is double, this will increase by double. If you look at the ratio also, 6 divided by 6, it will give you 1. 6 divided by 48, it will give you what? 8. That is, the ratio of hydrogen to oxygen in H2O is also here. It's also 1:8. Now, let's look at other application of this law. Let me give you further example of this. Now, assuming you are given 50 grams of hydrogen and you are asked to find the mass of oxygen in the same He2O. Now you can recall that originally, the mass of hydrogen is 2 grams, while that of oxygen is what? 16 grams. You know how we got this from the atomic masses. Okay. Then you now have 50 grams of hydrogen. How many grams of oxygen will you have? It's simple. If 2 grams gives you 16 grams, 50 grams will give you how many? What do? You cross multiply. Then you have here 2 grams multiplying x gram, which is equal to 50 grams multiplying 16 grams. What will you have there? So it means for this, you divide both sides by 2 grams because we are looking for x. Both sides by 2 grams. These 2 cancel this x. This divide this, it will give you what? 8. Now have 8 times 50, which will give you 400 grams of oxygen. 400 grams of oxygen. Now, having gotten this, now let's look at exercises. Look at this exercise. Question number 1. A pure sample of sodium fluoride contains 35 grams of sodium. How many grams of fluorine are present in this sample? Now here they've given us the atomic masses of. So what is the first thing that you have to do is solution. What is the compound that is involved? Sodium fluoride. And we are given that the atomic masses. So we have 23 grams. This is atomic mass of sodium. Sometimes you'll be given this, sometimes it may not be given to you, but you have to know it from the periodic table. So you have 23 grams of sodium combining with 19 grams of fluorine. So a pure sample of sodium fluoride contains 35 grams of sodium. So we now have, so if we have 35 grams of sodium, how many grams of fluorine will be able to combine with these 35 grams? So we don't know the mass, we're looking for the mass of this fluorine. Just like you saw in the last one that I solved. So if 23 gives you 19, 35 will give you how many? Just cross multiply. So we have 23 grams multiplying by X gram of fluorine will be equal to 35 grams of sodium multiplying with 19 grams of fluorine. So we are looking for X. So you divide both sides by what? 23 gram. Divide both sides by what? 23 gram. This 23 gram cancels this 23 gram. Then you are now left with 35 times 19 divided by 23, which is going to give you 28.9 grams of fluorine. That is it. So let's consider another equation, another exercise. It's simple. Solution. We are told that the question said if there are 42 grams of hydrogen in a sample of pure methane, how many grams of carbon are present? What's the first thing? Write down your compound. CH what? 4, which is methane. So we are told that in methane, so the atomic masses we are given that 12 grams. If you look at methane, 12 grams of carbon gives you, so this is 4 here. Remember that the atomic mass of hydrogen is 1. So with this 4 multiplying it, you have 4 grams of what? Hydrogen atom. Then the question now said, if there are 42 grams of hydrogen, so we are given 42 grams. So you put it for hydrogen in a sample of pure methane. How many grams of carbon? That of carbon, we don't know. Just like the other one, 12 grams gives you 4 grams of hydrogen. X gram of carbon will give you, what do? You cross multiply. Are you following? You have to follow. So you now have 12 grams of carbon multiplying 42 grams of hydrogen, which is equal to X grams multiplying 4 grams. You are looking for X. So you divide both sides by what? 4 grams. Divide both sides by 4 grams. So this divide this, and then divide here by 4 grams. So 12 times 42 grams divided by 4. This will give you 126 grams of carbon. Is it clear? Now let's take one more solution or exercise. This one said, so solution. A sample of carbon monoxide contains 42 grams of carbon and 56 grams of oxygen. If another sample of carbon monoxide contains 32 grams of carbon, how much oxygen should it contain to follow the law of definite proportion? We have CO, carbon monoxide. It contains 42 grams of carbon and what? 56 grams of what? Oxygen. CO. Then another sample of carbon monoxide contained 21 grams of carbon. Where did you put it? Put it for carbon. So have 21 grams of carbon. Say how much oxygen should it contain to follow? Oxygen, we don't know. What do you do? Just in the same way. You cross multiply. 42 gives you 56. 21 will give you how many? This multiply this, while this multiply this. So you can now have 42 times by x in gram equal to 56 times by 21. We are looking for x. Divide both sides by 42. Divide both sides by 42. So 42 grams will kill 42 grams. You're now left with 56 times 21 divided by 42. What will that give you? That will give you exactly 28 grams of oxygen. That is the end. Thank you. I hope that this is clear.